So, good day everyone. This will be the presentation for the pre-lab discussion of exercise 1 entitled Chemical Microscopy. So, for the objectives of this module is first you have to learn the basic principles and operation of the microscopes. Okay? Then the next one is for you to describe and illustrate the essential features of the authentic samples. And lastly, for you to evaluate the microscopic structure and identify the possible adulterants present in your unknown sample. So, basically, in this exercise, you will be provided with a specimen and you'll have a glimpse of the uh, feature of the specimen, which is your unknown. And then you have to identify the identity of your unknown based from the standards that we will be providing to you. So for the significance of chemical microscopy, so first, we have the examination of adulterants. So yung adulterants natin will be discussed later on, but in this aspect, we examine adulterants in such a way that we can see it via microscope. And we can see the features of each granules that may differ from other specific features of granules that we can classify the part of that specimen as adulterants. For the next part, microscopy reveals much more clearly the nature of adulteration than chemical analysis. Okay? Medyo physical yung ating approach when it comes to microscopy kasi we can see physically kung ano yung or madi-differ natin physically yung different granules from the standard. And by then, we can see if may adulteration yung ating sample. The next is for you to easily and quickly examine your sample via microscopy. Kasi imamount mo lang naman yung inyong sample sa microscope and you have to look through the specimen kung may adulteration bang nagaganap. Alright? Then, last significance is possible to approximate the percentage of adulterant present. Okay? So, what are the functions of chemical microscopy? So, pwede tayong magkaroon ng chemical analysis, imaging, structure determination, spectroscopy, in terms of surface, electrical and optical, and nanolithography. So, yung nanolithography ay application siya ng nanotechnology wherein nilalagay mo yung fabrication ng inyong nanomolecules sa surface nung ating material. So, meron tayong patterns na very detailed yung pagpa-pattern in such a way na yung difference is in 100 nanometers. So, by then, we can see that through the microscope. Okay? So, we have several microscopic techniques. So, these are the following. So, we have optical microscopy, scanning probe microscopy, and electron microscopy. So, for Chem 131, we will just be focusing on conventional light microscopy. Okay? So, this will be the classical technique na ituturo pa rin sa atin. So, for the conventional light microscopy, we make use of an instrument which contains one or more lenses to produce an enlarged image. So, these lenses are via optical system of compound microscope, which includes the objective, the eyepiece, and the condenser. So, as part of your review, and this is the parts and the functions of each in the microscope. So, ito yung parts niya from A to K. Alright? So, you just have to be familiar with this. So, basically, review lang ito from your high school, di ba? Next is for you to determine the calculation of approximate magnification. So, it's just the product of the magnification number of the objective and the eyepiece. Okay? So, we have different ranges of magnification. We have the low power, we have the medium power, and the high power. Okay? So, ang next natin dito is, bakit iba-iba yung ating magnification is for us to physically identify the possible presence of adulterants. So what are the adulterants? So these refer to the pharmacologically active ingredients added to our sample to give either synergistic or antagonistic effects. Okay? So this is the general description of adulterants. Pero for the context of food and feed, so for chemical adulteration, according to the Federal of Food, Drug and Cosmetics Act of 1983, so the food is adulterated if it meets the following criteria. So first, it bears or contains any poisonous or deleterious substance. So kapag ito ay poisonous, so meaning antagonistic yung effect. So kapag yung meron tayong substance present dun sa ating sample that can be antagonistic, has an antagonistic nature, so adulterant yung tawag din sa kanya or considered siya as adulterant. Next, if it contains any added poisonous or added deleterious substance, so siya ay adulterant. Next is if its container is composed in whole or in part of any poisonous or deleterious substance, even the container. Sabihin, for example, you have a sample of starch. So, nakalagay siya kunwari sa sako. Kung yung sako natin ay composed of some material that can be poisonous or pwede kasing through time, merong mag-adhere na matter dun sa ating sample na nanggaling sa ating container. So, pwede ring tawaging adulterant yung container. Okay? Next is if it bears or contains pesticide, chemical residue that is unsafe. So, usually ito yung sa mga agricultural products natin, no? Na may application of pesticide. So, kapag hindi na tanggal yung mga yon before it is offered to the market, so yung treatment ng ating mga materials ay considered as adulterated if may mga pesticide pang involved. Okay? Also, if it contains an unsafe food additive, so considered din siyang adulterant. And it is or it contains an unsafe new animal drug. So, paano yung new animal drug? Ibig sabihin, if we have injected something in our animals na kinokonsume ng tao, so possibly, it can be adulterated as well. Kasi, yung treatment dun, for example, sa chicken, may in-inject ka dun para mas mabilis mag-grow or mas malaki yung meat and so on. So, basically, yung chicken mo ay adulterated. Next is if it contains an unsafe color additive, so adulterated yung ating food. Or if it is filthy, putrid, or decomposed substance, meaning unfit ng kainin, so adulterated na rin yung food natin. Next is it has been prepared, packed, or held under unsanitary conditions, so adulterated na siya. Basically, lahat ng sinasabi ko ay adulterated yung food kapag antagonistic yung effect sa atin when we consume it. Next is it has been irradiated with and the irradiation processing was not done in conformity with a regulation. So ito ay adulterated as well. Lastly, next is it contains a dietary ingredient that is present at a significant or unreasonable risk of illness or injury under the conditions of use recommended in labeling. Sabihin, for example, daily consumption ng ating drug is supposed to be 10 milligrams lang per day. Pero when we have consume more than 10 grams, or meaning nag-exceed ka dun sa label claim mo, adulterated pa rin yung food. Okay? Then lastly, if a valuable component was omitted in whole or in part, and replace with another substance. So, eto, hindi naman siya antagonistic yung effect, yung last na part, kasi pwedeng may tinanggal lang dun sa ating, substance, then pinalitan ng, for example, extender, ganyan. So, yung mga extender na tinatawag natin ay adulterant, okay? So, it may be synergistic or it may be antagonistic. Pero tong effect na to, once it was replaced in part of the whole ng ating substance, so considered as adulterated yung food. Okay? So for us to operate this, we have to make use of the microscope, diba? So first, we have to start with the lowest power objective lens. So we do that by cranking the lens down as close to the specimen as possible. So sa ating operation of microscope, yung pinakamalapit na possible na pwede ng objectives natin dun sa slide or dun sa specimen, ginagawa natin na hindi dapat magta-touch yung dalawa. Kasi magsusmudge yun sa ating objectives. And mamaminusan kayo sa lab performance when you do that. Next is possible kasi na mag-crack yung ating slides or yung ating lens. Kaya dapat you have to be very careful when you crank the lens down when you mount your sample. Next is look through the eyepiece and focus upward only until image is sharp. Alright? So, upward na yung pag-focus natin kasi naibaba na natin yung lens ng closest possible doon sa specimen. So, kapag tumingin ka pa sa eyepiece at binaba mo pa yon, sabihin, babangga na yung lens natin doon sa yung lens ng objectives doon sa ating slide. So, iniiwasan natin yon. That's why yung pag-focus na natin ay we start by focusing upward until the image is sharp. Okay? Then, since we have started with the lowest power objective, kapag nagkaroon tayo ng sharp image, mag-next na tayo ng objective. So, set up na natin siya dun sa next power lens and do fine adjustments. So, these are the techniques used for the preparation and mounting. So, it can be of full mounts if your sample is less than 200 micrometers. Okay? Kapag naman liquid and viscous yung ating sample, we can do smears. So, isi-smear lang natin yung ating glass slide. Then, kapag naman masyadong malaki yung ating sample, we ini-squash natin siya. Since we have materials greater than 180 micrometer. So, ini-squash natin siya, then sinisieve para maging homogeneous yung itsura ng ating sample, then tsaka natin siya ilalagay sa slide. Then for the evaluation of microscopic structures, we have this. So we have 5 features or morphology. First is the size. The next is shape. Then markings, groupings, then the presence or absence of hilum. So dun sa una, sa size, it can either be small or large. So yung small natin ay 5 micrometer or less. Then for large naman, it would be 40 micrometer or more. For the shape, so meron tayong 4 na categories. We have circular, oval, polygonal, and elliptical. So, yung shape ng ating granules can either be circular, oval. So, kapag hindi na pumasok sa circular, oval, doon na yun sa polygonal. Then, elliptical. Alright? Then, for markings, pwede kayo makakita ng markings as you look through the specimen. So, it can either be dots, or lines, or spots, present dun sa ating granules. Then, we can have also groupings. So, pwede siyang singly, or groups of 2 or more, or by clusters. Then, we have the presence and absence of hilum. So, yung hilum natin is the nucleus of a grain starch. Okay? So, it can either be a mark or a scar, and a point of attachment to the ovule. So, if hilum is present, it can be identified by the position of the hilum in the granule. So, yung position niya can either be central, at apex, lateral, and etc. Okay? So, next natin is we'll have examples. We'll have examples of microscopic structures.